Hi viewers, you are welcome to Catch Up Maths channel. So in this tutorial, we are going to use this function with their maclaurin series to solve the given question over there. Okay, in this place, the first question you are given is you have to find the maclaurin series of this function, where the function is x squared cos x. So now in this question now, you don't have to stress yourself while looking for the derivatives. You don't need that. So the only thing you need here is that you already know the maclaurin series for cos x right from the table. So we have cos x with this. That is since cos x is n is equals to 0 to infinity minus 1 raised to the power n, s raised to the power 2n divided by 2n plus 1. Okay, if that's the case, the implication is that cos x is the same thing as this. Okay, now from the question you are given, which is f of x to be x squared cos x. Okay, you can just, let me call this place to be equation 1 and let's call this to be equation 2. So we can actually substitute equation 2 into equation 1. So in the equation is that anyway, you see cos x in equation 1, you substitute this thing inside that. So that is f of x is what? X squared multiplied by, we have our cos x, we have the maclaurin series of cos x to be this, which is summation n is equals to 0 to infinity minus 1 raised to the power of n, s raised to the power of 2n divided by 2n factorial. Okay, if that's the case, you can have f of x to be n is equals to 0 to infinity minus 1 raised to the power of n divided by 2n factorial, then s raised to the power of 2n, then multiplied by x squared. Now from this, when you look at this, log of the same base, that you have s raised to the power of a multiplied by s raised to the power of b. This will actually give you what? S raised to the power of a plus b. If the relationship between two functions is multiplication, so you are going to add their index together. Okay? From this, you obtain n is equals to 0 minus 1 raised to the power of n, 2n factorial, then s raised to the power. You pick one of the x, then you take the sum of their power, which is 2n plus 2. And this is summation n is equals to 0 to infinity minus 1 raised to the power of n, 2n factorial, then s raised to the power. Here you can factorize 2 out, then you have n plus 1. So this is the maclaurin series of this function. So the maclaurin series. Okay, question 2. You have f of x to be exponential 2x. Exponential 2x. When you look at these, don't forget the first thing is that you have to recall that maclaurin series of exponential x is going to be n is equals to 0 to infinity s raised to the power of n divided by n factorial. So this is actually from this table. Okay, if that's the case, let us assume you have something like exponential dash. Okay, instead of having x here, you only have this thing there. So that is, anywhere you see x, just put this. This will be what? Summation n is equals to 0 to infinity. And you have this raised to the power of n divided by n factorial. Okay, now I want to use this simple method to solve this question, where f of x is given to be what? Exponential 2x. Now don't forget we are looking for the what? Maclaurin series. Okay, in a place where you have dash here, so what do you have here? 2x. So instead of putting this in this place, now what are you going to put now? We put 2x, and this will be summation n is equals to 0 to infinity, then this will be 2x raised to the power of n divided by n factorial. Okay, if you like, you can still write this as summation n is equals to 0 to infinity, then 2 raised to the power n x is power n divided by n factorial. And this is the maclaurin series of this function. Thanks so much, guys. Don't forget to subscribe and like our channel. Good day.